Hi, we are Team CAST, otherwise known as COVID Autonomous Sanitization Technology. Over the past few years, life as we know it has drastically changed. The COVID pandemic hit the world just as we were growing used to the idea of crowded spaces such as buses, classrooms, and office spaces. Prior to the pandemic, many of us comfortably worked in spaces that look like this, but what we can't see, even now, is the bacteria buildup on the surfaces we interact with daily. The COVID pandemic highlighted a key problem in many industries. There are too many frequently touched surfaces and not enough people to sanitize them. As the pandemic got worse, the need for sanitization increased, but the workforce available to do so went significantly down as people stayed home to protect themselves and their family. Even with a proper workforce, normal soaps and spray chemicals give no feedback or consistent way to kill bacteria and viruses that make people sick. Effects of inefficiently sanitized workspaces are the potential hotspots for respiratory illnesses such as COVID, bacteria buildup that may cause people to stay home sick, resulting in loss of household funds and workforce, bad company ratings and sale declines, and in the worst cases, even death. Our solution to this problem is to create a robot that requires minimal human interaction, operating at level 1 autonomy, and provides a way to sanitize in a quick and uniform manner.
Generally speaking, the robot's base movement is going to be a man controlled with an Xbox controller, and the arm will operate autonomously and sanitize all surfaces. Sounds pretty simple, right? Well, it's not that simple, and there's a lot more that goes into it. To get into specifics, the whole system will be powered by a battery. That battery will turn on two fundamental pieces of the robot. The first piece is what I call the base. The base is the Scuttle robot, which will control the robot's movements and will additionally house an important microcontroller and sensor. The sensor is an RP LiDAR A1M8R6, which will be used to scan the robot's proximity in a 2D plane. The purpose of the LiDAR is to prepare future teams to make the robot have a level 2 autonomy, and for the LiDAR to continuously scan the proximity to sense when a table is nearby to turn on the UV lights. The microcontroller is a Raspberry Pi 4 with 4 GB. This is the brain of the whole system. It will choose what actions the robot should take based on the robot's sensors by communicating data it receives from the sensors to the various motors on the robot. Additionally, the onboard Bluetooth will communicate with a gamepad controller that a user would use to move the robot around. The second fundamental piece is the autonomous arm of the robot. The arm has its own sensors, actuator, and of course has the UV LEDs that will sanitize the surfaces. The arm will have 3 time-of-flight sensors that will continuously shoot a laser parallel to the arm, so when there's an object that breaks the light beam, the arm will then move out of the way to not hit the object. The arm will move around objects on the desk using a linear motion CNC stepper motor, which will move the arm up and down while keeping the arm parallel to the surface being cleaned. This will ensure safety of the user and uniform sanitization. To ensure that viruses and bacteria are being effectively killed, we are creating a standalone device that will indicate functionality with an LED. The bacteria killed indicator will use a Arduino Nano 33 IoT microcontroller, which processes the data received from the UV light sensor. The IoT capability of the microcontroller gives potential for future alterations to our design, maybe connecting to an app or database.
Our product has an affordable design with the cost of our robot being $2,000. This may seem like a lot, but when you break it down, this is the same price you'd pay for one employee making $10 an hour, working 40 hours a week for only 5 weeks. Similar devices range from $10,000 to $15,000 because they're targeted at large hospitals and not meant for office spaces and conjoined housing.
These are some of the benefits of killing bacteria with UV light. Over the last few years, safety has become the #1 priority at companies with the worldwide COVID pandemic, and even as we move past, we can always do more to prevent the spread of bacteria. Killing bacteria with these UV lights prevents the need for a bigger workforce for sanitization, and this results in less exposure to these harmful bacteria. UV light is also known to kill viruses very quickly, with one LED taking as little as 3 minutes and an array or 10 of these LEDs taking less than 5 seconds. These times are also measurable and consistent. If you have multiple arrays of LEDs, you can sanitize multiple areas at a time. Now let's take a look at the scenario before, specifically an office desk. Even though you may not notice, just a day's work can result in a lot of potentially harmful bacteria around an area. This is where our product would come in very handy. The automated arm with UV lights could sweep across these surfaces with the correct calculated time to kill this bacteria.
Did you get all that? Let me recap. Our solution is an operable device that uses arrays of high-powered UV lights to sanitize common touch surfaces. The operator maneuvers the base of the device around the desired surface to be sanitized. The LED rays are fixed to a mobile arm that keeps them a specific distance from the surface while detecting and avoiding obstructions such as computers, pen holders, or other usual office supplies. The arm also provides feedback to the operator of which parts of the surface have been sanitized. Our solution removes the operator from the hazardous area and replaces traditional sprays for sanitizing surfaces. CAST is dedicated to making your work and living environments safe again through the use of technology. If you have any questions about our solution, you can reach out to our team email. Also, this project would not be possible without the support of our technical advisor, David Malloway, and our sponsors, Dr. Saurabh Biswas and Donald Bowen. Thank you.